Good day, ladies and gentlemen, friends and neighbors, boys and girls. Today we're going to hopefully finish Lesson 6, Unit 0, Lesson 6, Part 3. This is an extension, certainly, of Lesson 6, Part 1 and Part 2. So today we're going to primarily focus on, well, one of our topics of discussion will be cube roots. Let's go with the definition. The definition of cube root of A is B only if B cubed is A. This is our definition of what a cube root of a number is. And cube roots will be either positive or negative. And here's our first example. The cube root of 8 is equal to 2. Why? Since 2 cubed is equal to 8. This is straight from the definition. And the cube root of negative 8 is negative 2, since negative 2 cubed is negative 8. So we're going to simplify cube roots. We're going to use the properties of radical expressions to simplify these. The other thing I will note, and we noted this in another video as well, that we can do fourth roots, fifth roots. We can do any root, and it's always going to be, if I have this guy right here, that's going to equal A to the nth, and we call this the nth root. There are some IXLs that will deal with fourth roots and fifth roots, and that's okay. But the same properties holds most of the time when you simplify these root radical expressions. They call them radical expressions or nth root expressions. You can use these two same properties as we're going to use on simplifying cube roots, and it's these properties right here. The cube root of A times B. The cube root of the product is the product of the cube roots. So the cube root of AB is equal to the cube root of A times the cube root of B, and we're going to use this to simplify a cube root expression. A simplified cube root, similar to a simplified square root. A will have no factors that are cubes, nor will there be a cube root expression in the denominator. So just FYI on that. And then property 2 is that the cube root of fraction is the cube root of the numerator divided by the cube root of the denominator. And the first thing we want to point out is the typo in these examples. This is the cube root of 135 and the cube root of 16,343. So the cube root of 135, what I need to do is I need to find, does 135 have any factors that are cubed? Well, we're thinking about that a minute, and I would just have to investigate that. And if I did some investigation with my calculator, I could see that the cube root of 135 was the cube root of 27 times the cube root of 5. And the cube root of 27 is 3. Why? Because 3 times 3 times 3 is 27. So this is the cube root 3 times the cube root of 5. That's what this guy is simplified as. So the cube root of 135 is 3 cube root of 5. 27 times 5 is 135. Okay, and the cube root of 27 is 3. Here's an example over here. The first thing we're going to do with this example is we're going to write that as the cube root of 16 divided by the cube root of 343. And you may take some investigation as to factors that are cube factors. 2 times 2 times 2, 3 times 3 times 3. And having said that, I think the numerator is going to be easy to see that this is going to be the cube root of 8 times the cube root of 2. And the cube root of 8 is equal to 2 because 2 times 2 times 2 is equal to 8. And we could write that up there if you want, and we could do that with cube root of 27 too. The cube root of 27 is equal to 3. Why? Because 3 cubed is equal to 27. This will kind of get an idea where these cube roots coming from. cube root of 8 is equal to 2. I have it right here. Why? Because 2 cubed is equal to 8. Okay, now 343, I just have to start factoring 343. And I can see right away, I just got to take my calculator and start factoring that. And with a little bit of investigation, I can see that 343 is equal to 7 cubed. And that's not a bad way to write it. And down the road, when we start turning these things into rational exponents, they might be a little bit easier to simplify. Well, what's the cube root of 7 cubed? That's going to be 7. So if we simplify this, we can simplify this particular expression. The cube root of it is 2. I still have the cube root of 2. And the cube root of 7 cubed is just 7. So this expression simplified is equal to this expression. Okay, so now we're going to write right here, we're going to write this cube root expression as a rational. I have the root expression, we're going to write that as a rational expression, and right here we go. We're going to use this property that I have circled in yellow up here. There's a lot going on in this particular lesson. Still a vital review for our pre-calculus, upcoming pre-calculus, and more importantly, our calculus. So this cube root of a is simply written a to the 1/3 power. This is a rational exponent. So I have a cube root expression written as a rational exponent. And we're going to use those laws of exponents that we discovered whether we didn't discover, that we reviewed a few lessons ago. All right, so let's see what we can do with this guy right here. Write the following as a rational expression and then simplify them using the laws of exponents. All right, well, this is going to be 8 squared to the 1/3 power because of that 1/3 there. Now, so that's going to be, I'm going to write it down here, 8 to the 2/3 power using the power to a power law of exponents. This actually should say rational exponents. I think I've used the wrong terminology here. This should be rational exponents, is what that should be. Whenever you see rational expression, let's put that word exponent in. Okay, so now I'm using the power to a power rule. 8 squared to the 1/3 is 8 to the 2/3. And I can also write that, can I not, 8 to the 1/3 squared, because of the power to a power. And we know 8 to the 1/3 is the cube root of 8. So this is actually equal to 2 squared, which is equal to 4. Soak that in for a minute. The cube root of 8 squared is 4. Doesn't look like 4, but it certainly is. Now we have the square root of 16 cubed. And I'm going to write that as a rational with rational exponents. That's going to be 16 cubed raised to the 1/2 power, which is equal to 16 to the 3/2 power, which is equal to 16 to the 1/2 power cubed. And what do we know about 16 to the 1/3 power? That's the same as 16, the square root of 16. That's what this is cubed. Well, we know what the square root of 16 is, 4. So that's going to be 4 cubed. And 4 cubed we know is 64. So this guy doesn't look like it, but that is 64. It certainly doesn't look like it, but it is using laws of exponents. So all we're going to do is turn write these expressions using rational exponents and then simplify them using the laws of exponents. Okay, so let's use the laws of exponents on this rascal right here. Okay, we're going to go, this is going to be negative 8 to the negative 2/3. This is going to be 27 to the negative 2/3. Those are both negative 2/3. And the first thing I'm going to do is I'm going to swap that and make these exponents positive. So this is going to be 27 is going to come up here on the top to the positive 2/3. And the negative 8 is going to come down here on the bottom to a positive 2/3. And now I'm going to use that power to a power, and I'm going to write that as the cube root of 27, because of this guy right here, squared over the cube root of negative 8 squared. And we know the cube root of 27 is 3, so I have 3 squared. I know the cube root of negative 8 is negative 2, so I have negative 2 squared, and that rascal is going to be 9/4, and certainly doesn't look like it. Alrighty, soak that in. These are good examples to write down and to study, and you'll have plenty of IXLs, as I said, to practice this. Well, the first thing we're going to do on this example is we're going to write that as 9 to the 1/2 power cubed. And what is 9 to the 1/2 power? That's the same as the square root of 9 cubed. The square root of 9 is 3, so this is 3 cubed, which is equal to 27. I'm going to write down a couple more examples here. Just 2 more examples to be exact. This guy right here, 16. And we're going to 125, 125 to the 2/3 power. So you could put this in with your calculator, but excuse me. But if I need to learn the laws of exponents, so this is going to be 25, the cube root of 25, that's what this guy right here does, squared. Well, the cube root of 25 is going to be the cube root. 25 is 5 cubed. And that thing is going to be squared. 5 times 5 is 25 times 5 is 125. So that's going to be 5 squared, which is equal to 25. And one more example here that we're going to put down. We're going to go 64 over 27 to the negative 1/3 power. Well, we should know what to do with the negative 1/3 power. We can distribute that to the numerator and denominator right here. Now I have these negative exponents, and their bases can from downstairs go upstairs, and upstairs to downstairs to make them positive. And I know what the cube root of 27 is, the cube root of 3 cubed, and 64 is the cube root of 4 cubed, which is equal to 3/4. Okay, some very good examples. Kind of a tough topic. Let's do a couple other. So this rascal here is probably one of the most misunderstood topics in all of pre-calculus mathematics, algebra, algebra 2, pre-calculus even. So we're going to use the same properties and laws of exponents with this square root and cube root expressions. This guy right here, if this is a red star, you have to know that the square root of x squared is absolute value of x. Absolute value is always positive, and I also noticed that, and I also said that if I have the square root of an object, that thing is always positive. That's always positive. And so if I have the square root of x squared, that's all, it has to always be positive as well. A good example here of this dude, what is the square root of negative 3 squared? Well, the negative 3 squared is 9, so that's the square root of 9, which is equal to 3. And what is 3? 3 is the absolute value of negative 3, because I started with negative 3. I'm going to end with, if I'm square rooting the square here, I could write this guy right here. The square root of this thing squared. It's not negative 3, it's the absolute value of negative 3, which is negative 3. In like manner, if x is equal to negative 5, I have the square root of negative 5 squared is going to be the square root of 25, which is equal to 5, and 5 is the absolute value of negative 5. Okay? So this is a very important property in all of mathematics, actually. And let's see how we're going to use that. So I want to simplify this expression here. So these are square roots. If this root isn't given, it's a square root. So I'm going to do, this is going to be the square root of 8 times the square root of x squared times the square root of x. That's what this, just this expression is, minus 3 times the square root of 25 times the square root of 2x. And if you notice here, 8 times x squared times x is 8x cubed, and 25 times 2x is 50x. Now I'm going to simplify those things here. And the square root of 8, we know what the square root of 8 is. The square root of 8, I'm going to need one more step here. The square root of 8 is square root of 4 times square root of 2. The square root of x squared is the absolute value of x. I can't do anything with the square root of x. Minus 3, square root of 5 is, square root of 25 is 5 times square root of 22x. And look what I have left over here. I have the square root of 4 is 2. But what I'm going to do, I'm going to put the square root of 2 and square root of x back together. I can't forget about this absolute value of x. Square root of 2x, adding and multiplying these guys together, minus 15 square root of 2x. And if I want to factor out that square root of 2x, I certainly can. And if I did factor it out, the true simplification of this guy is going to be 2 absolute value of x minus 15 times the square root of 2x. That's the true simplification of that. Okay, just to review, get you used to rational roots, rational exponents and roots. All right, so let's try this other example here. Let's see here. This is going to be the cube root. I'm going to do the 16 first. And right off the bat, I see that 16 is the cube root of 8. And I still have the cube root of 2. And I have the cube root of x cubed. And I still have the cube root of x. All that is equal to, if you notice, all of that is equal to my first term here. X cubed times x is x to the 4th. 2 times 8 is 16. And I'm still subtracting from that here 5 times cube root of 2. You can't do anything with that cube root of 2. So all I'm going to do is simplify this. This is, dude, is going to be 2. This one here is going to be x, and I still have the cube root of 2x minus 5 cube root of 2. Cube root of 2. And guess what? That simplifies because I can't factor anything out. So this guy, dude, right there is already simplified. Let's do this example here. This example seems to be a bit convoluted. This is simply laws of exponents using rational exponents. So the first thing we're going to do here is we're going to write this as x squared 2 to the 1/3 is 2/3. This is going to be y to the 1/3. This is going to be x to the 2/3. Y to the 4/3. And I'm using power to a power all over x to the 2/3, y to the 2/3. Now, if you observe carefully, this are the same thing, so that's going to zero out. So the only x that I have left is this x to the 2/3. And if I times y to the 1/3 plus 4/3 over y to the 2/3. I still have the x to the 2/3. And this is going to be y to the 5/3. And I'm going to go ahead and use my quotient property, y to the 5/3 minus 2/3. Oh, which that's going to be nice. That's going to be x to the 2/3 times y to the 3/3, which is just 1. So this guy simplifies to x to the 2/3 times y. That's what this rascal there is. Okay. And for right now, we're going to forego this particular example. We're not going to have any problems like this. So at this point in our game, we're just going to cross that example out. I got to tell you, ladies and gentlemen, there's a whole lot going on in this video. So you might have to watch it. We're going to focus your area of review with some good IXLs with rational exponents, writing things as rational exponents, writing radical expressions using rational exponents, simplifying things like this. This is going to be an important skill here. This will be an important skill. This is tremendously important. This topic right here we talked about. We had some other things. This is going to be the nth root a to the 1 over n. We're just simplifying cube roots here. It's going to be important in this video. And then some expressions, some simple expressions, simplifying them, writing them in lowest terms using your laws of exponents and laws of square roots and cube roots. All right, so that's it for Unit 0, Lesson 6, and we'll talk soon.